but they're not. So they could never be a long-term reliable battery.
It's been a minute, but I have some experience now with these Global Power batteries, and there's two issues that I've found that have caused me problems, and I'm here to fix one of them today and talk about the other one. When I initially reviewed these, I did talk about how they weren't top balanced when I did the reviews. Some of them charge up to about 14 volts, where the sticker says you can charge up to 14.6. With a perfectly top balanced battery where each cell is given to 3.65 volts, you will reach 14.6 volts. But some of these cells were not in balance, and one of them was reaching 3.65 before all the others, and the others might be down in the 3.4 range, hence 13.8, 14 volts. And a lot of people have commented and reached out to me about experiencing the same thing with their batteries. And the big deal here is that the BMS itself typically takes care of this. And so you might have a battery that's been sitting for 6 months on a ship from China, and it reaches you and the batteries have gone out of whack a little bit, but then with some charge and discharging cycles, the BMS can pull the voltages of the cells together and make it to where you can then charge to 14.6. That's how it would typically work with a battery that I would expect to have a good BMS. When I tested this, I didn't think about the fact that this could be not working in the BMS. And I don't know why I didn't think about that, but I didn't. And sure enough, this BMS, and I even confirmed this with the seller of the batteries, at least here in the States, and he doesn't manufacture them, he's a reseller, does not have a balancer in it. Which initially I was like, well, it's unfortunate, because that would probably have fixed the problem. But maybe the cells won't go out of balance and it'll be fine. At least not any more out of balance than they are, because when I tested my battery, it still tested 105 amp hours, and that's the reason that I still recommended the battery, is because while the cells were not fully in balance, the battery still tested at full capacity. And that would be the concern with not being able to use the full voltage range of all of the cells, is that you wouldn't get all the capacity out of the battery, and I was getting the full capacity. The problem I had, though, is that during this winter storm that we had here in Texas, here a week or two ago, I was using my Global Power battery. It was handy, and I was using it to power my fireplace. Since the last storm we had back in February of 2021, I had installed a fireplace insert in our house, and that way I could burn wood and heat up at least the room or the downstairs of our house here in North Texas, and not have to rely on electricity or gas or whatnot to do it. I'd say not rely on electricity, not rely on much. My house is all heat pumps and heat strips, which require quite a bit of electricity to run, and not something you could run on a little battery like this typically. So what I did is I had this battery, 1.2 kilowatt hours or so, and that could run my blower fan inside of the insert for about 24 hours or so before the battery would be depleted. And that's fantastic, because then I could have some solar panels out, and even if they've got some snow on them, they get a little bit of charge, and I can make it quite a ways on just one of these batteries. But something that I mentioned in my past video was that the symptom of the batteries not being balanced and the BMS cutting off when one cell reaches full, which is what it should do, is that you'll see the voltage spike. So as I'm running this, and there was a few days of cold weather, one day the sun had come out, battery got all the way charged, and my inverter started complaining to me. So it started beeping at me. Sure enough, high voltage alarm on the inverter. And that was indicative of the BMS cutting out. Now, I had set my charge controller to only charge to 14 or 14.4 volts, keeping in mind that I had already balanced that battery. I had built myself, this is an active balancer, and I had built these cool little leads to where I could plug in the active balancer as well as the BMS at the same time. I stuck that battery on a charger for a day or so and got all the cells up to 3.65 volts. So that battery was perfectly balanced, and I was like, good. So I got the batteries balanced, or the cells inside the battery balanced. Now I can go use the battery and it'll be fine. It wasn't, because as the days progressed, I kept having to lower and lower the voltage on the charge controller to keep the BMS from cutting out due to one of the cells going to 3.65 before all the others. So the cells, even though I balanced them, which means it could be that these were top balanced at the factory, they were going out of balance as a normal course of charging and discharging. which tells me that I can't just balance it and leave it. I need to leave a balancer inside the battery, which isn't the end of the world. These batteries you can get for about 300 bucks. And this balancer, this is a 6S balancer, but you can get the 4S balancer, and it's about $45. And I was like, well, if there's a way that I can wire that in, then I would have a battery with an active balancer, which arguably is better than a lot of BMSs out there that have the passive balancing. So for 350 bucks, yeah, I had to take the battery apart to replace it, but that's still a pretty good deal for a battery that pulls full capacity and that you can pull 100 amps off of, 100 amps continuous through the BMS. So that's kind of what I'm here to do today, is can I easily, because it can't be something that takes a lot of time to do, especially if I'm suggesting that you could do that for your battery, whether you've already bought one or you're still looking for a battery and you'd be willing to pull it apart and put an active balancer in it. Is it reasonable to do? So I spent a lot of time researching what kind of wiring techniques I could use, because doing this here was a bit of a pain. I had a lot of soldering to do and a lot of little pieces to buy and cutting wires and stripping, and it probably took me an hour to put together this little thing, but the idea was that I would put together once and I could balance multiple batteries, balance this one and then take it out and balance the other one, take it out, balance the other one. Turns out that's not going to be the way that I can do it. So what I did is I got myself a new balancer here. And we're just got the 4S balancer instead of the 6S. I'm not sure why I bought the 6S in the first place, because I don't do 6S batteries, but I did. So it's got the leads in here, which we'll be able to use, and it has the 4S active balancer right in the package. And where else would it be except in the package? Little cute thing. So these work fantastic. I've been using these Heltec balancers, the capacitor-based ones, on some builds. For example, if you're putting together a 16S pack and you don't want to balance all the cells first, because when you've got, say, a 230 amp hour battery pack you're putting together, the common practice is to put all the cells in parallel. So you have 230 times 16 worth of amp hours, and then you connect a 3.65 volt charger to them and wait for them to all come up to 3.65 volts. That would be a parallel top balancing. It's a great way to do it. It works great. The problem is how long it takes. That could take a week or two, depending on the capacity, the state of charge of those cells. And a lot of people don't want to wait that long, whether they have the time to or not. So what I've been doing is I bought one of these that's a 16S, and I put little alligator leads on it. So now I can just build the pack, have the BMS on there, and then alligator clip all of my wires onto the cells, the bus bars, and then just go charge the pack. And over about 3 to 4 hours, the pack will be completely balanced, in my experience. So obviously that would change based on how far off the cells are from each other. The cells that I've been using are the Eve cells from a specific supplier, and they seem to be pretty close from the factory, and that's probably because they do a cycle test on them before they send them to me. So I would imagine that their machine takes them to about the same state of charge when it goes to discharge them. But that's been working beautifully, which is why I went with this for this unit. Now the difference between the capacitor based and there's another one that's like a resistor based, is that this actually looks at every cell and gets every cell within at the same voltage. There's one, and I don't have it with me, but it's a flat board. It's just got little like LEDs and resistors and whatnot on it. And I've used one before, and the thing is, first of all, it's a difference of like 0.3 volts or 0.03 volts. I think it's 0.3 volts that it has to be off, or 0.2 volts, which is quite a bit when you're trying to top balance something, because the difference between 3.4 and 3.6 is quite a bit. It's enough to be a difference, but it only looks at the two cells that are adjacent to each other. So you could have cell 1 be at 3.4, cell 2 be at 3.6, cell 3 at 3.6, and then cell 4 at 3.4. And it's not going to do any more balancing if it's a 0.2 volt difference between the cells. It's not going to make them any better. Or you could even have like a cell at 3, 3.2, 3.4, 3.6, and it would consider it absolutely fine, because it's not going to look at cell 1 versus cell 4. It's going to look at cell 3 versus cell 4, say this with intolerance, and it's fine. Whereas this is going to look at the whole set of cells and make sure that they're all the same. And you'll pay a little bit more for this, because these are like 40, 45 bucks, whereas the other ones you could pick up for 5 or 10 bucks, and there's a reason, because they really won't quite balance the whole pack. I digress. let's wire this into our battery. And what I'm gonna use are these. Now, you might be looking at this and going, Bean, why would you use these? These are commonly used in my experience, for wiring trailer lights into a vehicle. And after a few years, the wires corrode because now they're exposed to oxygen, and things cause a problem. Things cause a problem, they cause a problem. Then you have to redo your trailer lights and probably do it a different way or just continue the same way. But I'm figuring inside of a pack like this that you're not gonna have problems with oxidation. You're all well sealed, there's not water penetration, etc., etc. And they make it really easy to splice in a wire. So I don't know if you've never used these before, you have a place for 2 wires in here. One's a pass-through and one is an end. So you'll have one wire that just sticks in for example, for my balancer, and then I will have another wire, which is the sense lead that exists inside the battery that will pass through, and I'll just crimp this down, it'll connect the two, and that way I can have basically a pigtail off, a Y off, and have my active balancer plugged in as well as my BMS. So let's get doing on that. What we've got here is the sense leads. If you want to know what all's in here, this black and red wire is really just the screen here up top. These wires here, which often are glued in to some extent, but it's not a hard glue, it's like a silicone type thing. This one just popped right out. These are sense leads, that's what we're looking for. You can see the black leads coming through the BMS. So the P- goes up to the terminal here. The B- goes down to the battery, that's the negative to the battery. And that runs through the MOSFETs that will cut off charging or discharging respectively. There is a temperature sensor on top of the MOSFETs, and there's a temperature sensor on the cells. So, and really I think those two are more, those circuit breakers, not temperature sensors, so it's an on-off. So if the cells get too, I'm assuming these ones are too hot, then it will shut off. If the MOSFETs get too hot, it will shut off. And then there is a separate pair of temperature sensors for the low temperature cutoff, because one of them's a high, one of them's a low. So that's what's in here in the battery. But this is what we're worried about right now, is our sense leads. I'm gonna go ahead and pull this out of its little conduit piece. And how do we know which is which? Because right now we just have a bunch of yellow and a bunch of white wires. And here on the BMS board, you can see your B- through B4. So your B- or B0 is what a lot will call it, is right here. But it looks like our active balancer does the same way, and it's in the same orientation here. You got a B- through a B4 plus. B- of course goes to your negative terminal of the battery. Nothing here is going to be connected through the BMS. It's all on the battery side of the BMS. You don't want to connect your B- lead to the power side of the BMS. So let's get, and I don't want to have this connected to anything right now, because I don't want to power this up while I'm plugging things in. And you'll notice that this is unplugged too, which means the battery's dead right now because there's no sense leads. So I shouldn't be messing with any power. I mean, there's 12 volts across these leads here. So we do need to be careful, but at least the BMS is powered off. I want to look at the orientation here. So this is good. So our black is going to be our B-, so that'll make things easy for wiring up. Let's just grab pliers here, and we're going to stick this guy into here. Something to note is that this is not the only battery manufacturer that's going to have this problem. So while I'm talking about fixing these Global Power batteries, specifically, if you have a different lithium iron phosphate battery or lithium battery that's having a similar problem where you can't charge it all the way up, likely it's because the cells are out of balance, and doing something like this would fix it. The advantage of these Global Power batteries is that they're easy to get into, and that was one of the reasons that I went for these, is because I figured if there was a problem, such as what I found, then I could probably fix it, which I am. All right, so we scrunch that metal piece down, and that will give us a positive connection to that. We'll just do this to kind of lock it in place. And let me go grab my multimeter and we'll verify that that's coming across. I'll measure from this lead that I just plugged in over to say the positive terminal. I'm getting 13.32 volts. So that did, in fact, connect in. Something of note with these connectors, if you are worried about them not working, I figure the worst case scenario, if they stop conducting, is that your active balancer doesn't work anymore. But your BMS is still in place. So, is it that big of a deal? I don't know that it is. You would know. Nobody wants a failure, but at least in this case, it would not be a catastrophic failure. And all I'm doing now is just going to the next wire because they're all in order.
So once I had B minus of the BMS connected to B minus of the balancer, B1 of the BMS connected to B1 of the balancer, etc. I then just put a charger on this, and now what we're looking at is how much current is flowing between the cells. You can see we're up to about 1.2 amps on one of these cells. So balancer's definitely doing its job, and we'll just let this top balance to 3.65. Right, so the first problem that we're trying to fix here in this video was the imbalance within the battery. And so what I did is ran a capacity test before I started all this work. And so you can see here that I hit 89.9 amp hours with the imbalance existing.
All right, so we've hit low voltage cutoff, 102.9 amp hours. Side note, this is what you want to happen, is the inverter cut off, but the battery is still alive. So ideally at this point, and this is the way these inverters typically work, is once they cut off, they won't turn back on, taking that idle draw until after you manually reset them. With the hybrid inverters, you can change that behavior. With these little Ames inverters, it's just going to turn off until you do it, and that's why they got the little soft button on here instead of like a hard flip switch. I don't know, maybe the hard flip switch you would just turn it off and back on again. But this is the way it is. And what I was going to say is ideally the solar charge controller could stay powered up until the sun comes up and you'd be able to start charging the battery. Hopefully the battery doesn't discharge so much that the BMS cuts off before the sun comes up, because then you got to jump start it. But anyway, we'll see what this screen says. It says, I'm low. And let's check and see what the voltages are of the individual cells. 274, 285, 271, 280. Pretty close.
The other thing I wanted to talk about was another issue I found, because when I did my initial test, I did in fact run a load test to make sure that this BMS could handle the current. And it passed. The MOSFETs weren't getting hot, everything was fine. I was, however, messing with a different battery, because yes, I did end up buying some more. I've got 4 over in a cabinet, I've got this one, I also got the one at the house. And it was cutting out. It was pulling about 60 amps. I was charging the forklift with it, pulling about 60 amps, and after about 5 or 10 minutes, everything was just cut off. And I was trying to figure out what was going on, because I thought maybe the inverter was cutting out, because it was a cheap old modified sine wave inverter. Turns out that the MOSFETs were getting very hot. So I suspect the circuit breaker on there was cutting off, which was no good. And that's this battery actually is the one. So I will in fact be talking about a replacement for this battery.
I think I've had it with this battery. I can put together a battery myself, DIY, with the components that I've picked out, and it works the way that it's advertised to work. These things don't. And while they are lithium iron phosphate and they seem to have about the capacity that is advertised, it's frustrating because the discharge current isn't consistent from battery to battery. Some of them work at 100 amps, others do not. And some of them, I don't know, they're not in balance, and then they tend to stray from balance, which means the BMS is not balancing them at every charge. And if they had stayed more or less in balance, it would have been fine, but they're not. So they could never be a long-term reliable battery without a balancer inside. So I'm going through all these steps and I'm like, well, we can just add a balancer, it'll be fine, and this and that. And yes, you can make this battery work, but I think I've just had it to here today, and so I'm done. I'm going to put these batteries back together and stick them on a shelf, and maybe I'll come back to them later. But sure, put a balancer in. It'll keep it balanced and probably get 100 amp hours out of it, but don't expect 100 amps output from these. I don't know how people are using these in golf carts, because a 36 volt golf cart with 3 of these would be 100 amps, 3.6 kilowatts. I'm sure the BMS is cutting out. They're probably just chopping along as the BMS cuts in and out going up a hill. I don't know.